All right, so let's go ahead and pick up with our next feature, right? Multicast static route, right? The same game plan we're gonna have, our agenda, a quick overview. With this, again, being our proprietary method, what we're achieving here, we'll have a overview, the use cases, and then build with that basically the details, talk about the details of it, a little bit of the background, and then the caveats, and then configuration, best practice, troubleshooting, and then Daryl will do the demo for us again, and then additional resources. All right, so overview. Now, here's our basically with multicast static route overview in a smaller environment, let's say with few hops, right? Because we're not trying to replace the dynamic, right? In a large environment, we're going to need the dynamic, but we'll talk about the key uses of this multicast. But with multicast static route, right, what we're basically doing is allowing the user to configure a static multicast flow and program it directly into the multicast forwarding table instead of running your dynamic, right? Such as your PIM, sparse mode, and so on. Now, key thing to please note, what differentiates this with our other multicast routing protocols, that this feature does not depend on the unicast routing protocols. And we're going to look at that when we talk about the command line of that, how we configure the static multicast route. Okay, so this is the key. Please note that this method of ours does not depend on unicast routing protocol to build the multicast tree. Okay, now also it works like basically then in that sense it works like a standalone multicast route provisioning, right? And also interoperates with our sparse mode, or I should say PIM, not only sparse mode, SSM, and also as well. And then it also interoperates with our IGMP and MLD, right? So here, as you can see, the receivers using IGMP will join the group. And of course, the source, when the source starts sending the multicast stream, but at every hop, we statically provisioned, right, configured the multicast path all the way to the receiver. Now, multicast static route overview, some of the key things to keep in mind as far as interfaces supported, the supported interface type, the routed only port, SVI, L3 lag, Hydra sub-interfaces, right, for both upstream and downstream, right? And then also some of the features and sub-features supported for IPv4 and IPv6. And we will talk more in detail regards to a decent amount of this here, such as the SSDP, the simple service discovery protocol, right? And non-SSDP flows. Of course, static multicast configuration we'll talk about. Summarize static route configuration. And right now, for now, at least keep in mind, although we say summarize, it's just a default route. Okay, I'm going to emphasize on that again, and we're going to see it in the configuration. Redistribute static multicast routes into PIM. For example, because we interoperate with your PIM sparse mode and SSM, if you're running part of the network PIM dynamic and part of it you're running static, so we're going to use redistribution to redistribute between the static and the dynamic, right? Get those static routes, multicast static routes into the dynamic, so the dynamic site knows how to reach the other end. And of course, we supported features such as nonstop forwarding with the static multicast route, the in-service software upgrade, VSX support, VSF support, and as we said, interoperability with our PIM, right, sparse mode and SSM, and also interoperability with IGMP and MLD for IPv6. And some of the deployment cases here, as we're going to use this in our use case studies, right? Use cases, I should say. Deployment, you have your static only, like the one previous topology we talked about. So where we don't have dynamic, it's a small shop, few hops. So we're going to go ahead and provision this manually, right? Because if you, in a large environment, of course, the drawback is it would be an administrative overhead. So then hybrid mode, where you have partially for certain flows, you're doing static, and then for everything else, basically you're doing dynamic. Please note the static will take precedent over the dynamic. And then the redistribution method for deployment. So we have static part of the network, and then dynamic part of the other part of the network. To build communication between the two, we would need to redistribute, right? That static into the dynamic multicast routing. Supported platforms, multicast static routes for 6200 series, 6300, right? And 64, the 8320, 8325s, 8360s, 8400, and 10,000, right? So those are multicast static routes these platforms support. But when it comes to multicast static route summarization, please note that basically 84 doesn't support. And a simple version of that, they all support the multicast static route, but the summarize option is not supported within the 84. And we'll emphasize that again, just to make sure that we remember that. Use cases. As we said, in the small shops, right, in a small network where you have few hops, right? And again, we're not trying to replace the dynamic routing protocol. In a large network, you're gonna need that, right? And then also ability to override dynamic multicast, because we said also the static takes precedent over dynamic. So we can have a static for certain flows or certain parts of a network, right? Such as the default multicast route, right? Which would be a catch-all for certain parts. And that would be done with summarization. And then static into dynamic routing protocol with the redistribution, which we will take a look at that a little bit more closer coming up. And then some of the other use cases. Matter of fact, SSDP, Simple Service Discovery Protocol, is one of the key initiatives to have this feature. And we're going to get into that. We're going to talk about what is SSDP and some of the details of it, right? So here we're just listing it. Fixed channel subscription, IP video surveillance. The reason we say IP video surveillance, because if you have all these surveillance cameras and so on, and the storage, all these packets, all these surveillance cameras would be sending to the receiver, the storage area. So then we could perhaps do a static on that. And then, of course, your PTP, Precision Time Protocol. Now, in a static mode, first use case here, a static, as we said, is a smaller shop, right? Smaller shop. And so in this case, we have all these sources, video, surveillance videos, and then the receivers on part of the network where the storage is basically, we're storing these the recording of these sources are being sent to. So on every hop, and you notice here, although we're going to get into command again, but IP multicast static route, the incoming interface, the source IP, the destination / basically group, and the outgoing interface. So due to this, the way we have the static route, that is why the static multicast route is independent of your unicast routing protocol, right? And Daryl will show that in his demo as well. So then at every hop, basically we statically provisioned, right? And again, as we just said, it is this multicast static route is not dependent on your unicast routing protocol. And here's another example. Basically, when we look at the difference between multicast static route versus your CLI, right? Pretty much, hopefully everyone's comfortable with the router PIM, right? We enable the dynamic multicast routing protocol. In here, we have an IPM route 10.1.1./32, right? And 10.1.1.2. What are we doing with the above command? Basically, we're basically affecting the dynamic, right? By statically provisioning, configuring, changing the path of multicast stream. Multicast routing to use a separate path from your reverse path forwarding check, right? Because with dynamic multicast routing protocol, we rely on the unicast routing tables. And then we do a reverse path forwarding check to make sure the packet is received on a valid interface, right? Before we flood it out the next port. right? So, which is different from unicast routing, right? It still requires a multicast like your sparse mode to route these packets, right? This IP-M route, the static, it still requires your IP sparse mode, for example. So again, multicast static route programs multicast forwarding directly into the hardware without PIM. Okay, just wanted to re-emphasize on that a little bit more. But this is a use case of static environment, small shop. Now, when we look at your hybrid mode, right, with PIM, so we have on top, we have PIM, let's just say we have PIM running. And so for certain flows, right, such as your SSDP, for example, we have statically provisioned path for these flows, right? And so again, static will take precedent over dynamic, and we'll get into the reasoning. One of the reasons, because these protocols are too chatty, it could overwhelm the resources of the box, right? Both hardware and software. So when we have both static and dynamic multicast routing enabled, right, static will take precedence. Now, also please note, when you still have, let's just say you have two static routes, it's the longest prefix match, such as your S source and group is preferred over your any and group, the asterisk, right? This is your multicasting, right? So the SG is preferred over asterisk, comma G. And this is an example of that, right? Because IP multicast static route, // the incoming interface /2, the keyword any is the asterisk we're looking at, because we're not defining, maybe there's multiple source, you know what, end of the day, they all have to be stream out VLAN 40. So then in that case, you know, we're just going to use the keyword any to simplify. But if you have both static, as far as the S comma G and asterisk comma G, the longest match, just like our routing protocols, right? If we have within our unicast routing tables, right? When we have a /27 versus a /24 of the same subnet, the first 3 octets, right? Let's just say the longest match is always preferred, right? So same case here. Now, with redistribution, multicast static route into your PIM domain. So here's an example of a static route, static environment on the left side. So part of our network, we have a static. And then on the left side, we have our dynamic PIM, in this case, running. Now, also please note, so and of course, our receivers running IGMP, no problem. We have our source. Though on our CX switch, we will have to redistribute the static into the dynamic. And thus, this gives us also the ability for interoperability, right, with your dynamic, right, dynamic multicast protocols. Now, please note also, this gives us also flexibility to interoperate with vendor XYZ, right, with a third-party vendor routers or switches that are running multicast. So, but please note, in that type of scenario, the vendor XYZ is running dynamic, let's just say, and we're running our proprietary static on our CX switches. That R3, as you see here, the one that's going to be doing the redistribution, that has to be a CX switch, because it takes our proprietary static method and redistributes it into dynamic, which we are, is part of the standard, we're able to communicate with vendor XYZ, right? Now, details and some of the caveats. So a little bit of a background, right? With because this is one of the key initiatives to have this static multicast, because of the high resource utilization that is caused by simple your service discovery protocol, SSDP, right? And what are these protocols doing for us, right? This is a discovery protocol, right, at the application layer, right? It's one of the key protocols for universal plug and play. Now, as we know, anything that makes the life of the end user easy for things for end user, it really causes problem for the network administrator, right? So in the same case, they do the plug and play, but we have to deal with the hassle of how do we control all these plug and play devices in that case that are doing discovery that are causing high resource utilization on our boxes, right, on our switches. So SSDP enables network clients to discover network services by sending multicast discovery, and that discovery is sent on 239, 255, 255, 250, right? And with IPv6 FF0X::C, right? And though these discoveries, as you can see, they can really, because that you have large number of these users, these discoveries could really cause high resource utilization. And of course, with SSDP protocol is used by your Android devices, and these devices are typically large number, right? And though basically causing high utilization, and we need to manage them very carefully, right? We want to allow these things, right? End users are bringing, we have to allow, but how do we control it, right? So in addition, also, not only they have the discovery, but when they are sending their periodic IGMP joins, right? And then PIM on the behalf of the users will send a join to the rendezvous. So all these periodic join that are being sent, there are many of these basically control packets on the network can also grow large, right? So thereby causing high CPU of multicast daemons and possible interrupting the other operations. Now, solution, right? As I said, this is SSDP is one of the key initiatives that we have this multicast static route. So then solution being here, configuring summarized multicast static route to prevent high resource utilization, right? So here we have, well, with multicast static route, it gives the user the flexibility to basically program a specific path for the multicast, right? Because it's static, you're manually defining that path, right? And though it's not relying on the underlying protocols, as we said, it is independent of your unicast routing tables. So then in this case, we explicitly define the incoming interface, the source address, the group address, and the downstream interface. So when we look at it here, IP multicast static route, the VLAN 10 being the incoming interface, right? This is the incoming interface. And then source, in this case, rather than using a /32, we use the default route concept, any, right? And the destination 239, 255, 255, 250, and the outgoing interface 1/1/2, right? So we're explicitly configuring this. Now, we can configure that on the receiver side, so we can cut down all the chattiness of the protocols, such as the SSDP, as we talked about. An optional, we can look at when you have multicast static route configured on the source connected router, right? The PIM registration process for that source and group route will be suppressed, and the PIM join will be dropped. So and then in a scenario, let's just say, since optional, right? Let's just say the sources here, maybe on the same LAN, we have the source and the receivers. We don't need this join to go across. Though in that case, we can just configure this static entry on this device, on the source DR router. And that will suppress all those joins and drop those PIM join messages. Another case here we can look at when multicast static route is configured on a rendezvous router, right? If we had a rendezvous device here, right? It sends PIM registration stop messages if it receives a PIM registration message, and also clears pending registrations for the source and group, right? So this would be good, and the feature can be used for your handling of your SSDP, because since we're doing static for the SSDP flow, then we can go ahead and configure that on the rendezvous device to basically handle those join messages, so we can basically suppress them. Now, here's another case. To match any source, we set the keyword any in the syntax, right, in the command line, rather than using the source, right? After VLAN 10, you have a source, and the source should be /32 or any. Any is like the default route, right? So in this case, we're using, this would be referred to as our asterisk group, comma group, right? To avoid multiple routes, right? Rather than having, we have tons of sources, and it doesn't matter, right? From these receivers or from this interface here, the outgoing interface 1/1/2, it doesn't matter if I have 10 sources or just one source, still going to be this interface 1/1/2, right? So in that case, we can minimize and basically rather than putting multiple entries and programming that into the hardware, right? Save the resources of the hardware. Though optimize usage of the hardware resources due to the summarization and optimal CPU usage as SSDP packets not punted to the CPU, right? All right, so some scale information, please note, this is the unidimensional scale, right? Which is not as used in production, where the multidimensional numbers are more normally published in our validated solution guides, right? And more of a production case. Informational, you can always, of course, definitely important. You can refer to the slide deck for those numbers. Some of the caveats, let's take a look at some of the caveats. The static multicast route is not supported in 9300 series switch, and the static multicast route summarization is not supported in 9300 and also 8400. As we pointed that out earlier, the 8400 doesn't support. All right, so unsupported interfaces, basically your GRE tunnels and your VXLAN interfaces, both IPv4 and IPv6, right? We don't support. And then unsupported features or sub-features for both IPv4 and IPv6, private VLAN interoperability with PIM dense mode, right? Override of the PIM for sparse and dense and SSM, right? Partial summarization, again, we said the summarization, we use the keyword summarization, but it's only /0, right? 0.0, like a default route, right? The keyword any. Or you can have basically /32, specific source IP address. And IPv6, we have a /128. Okay. Precedence and backup routes and not support expiry time for multicast static route, reverse path forwarding check, support for multicast static route upstream, not supported, multicast static route configuration on the network with equal cost multipath, right? For both downstream and upstream is not supported. Because if you do that, you may have duplicate, right? Then you're gonna run into the duplicate streams coming down. And again, please note, this is our proprietary method on our CX switches. All right, so configuration, right? From our configuration point here, IP multicast static for IPv4, we said incoming interface, the source IP address /32 or any you can use, the group address, the destination, right? And the outgoing interface. And option also, if you have multiple VRF, by default, it would be default VRF. But if you have other VRFs, then you want to identify that VRF. Okay. And same thing with IPv6, rather than IP, then you have IPv6, same syntax, right? Pretty much just V6 in there. The show IP multicast static route, right? Command, we can take a look at it with the options of group address, the source address, and or all, or with the VRF. Same thing with V6. Show capacities multicast static route, or you have, so one will show the number, right? What is the max you can have? The other will show how much, based on your configuration, how much resources are available, the capacity of the box. Now in here, you can look at the syntax, IP multicast static route, incoming interface VLAN 10, source IP 10.10.1.2 basically /32, right? And 239.255.255.250, the group, and the outgoing interface, VLAN 20. As you can see, that would be our S, G. The next syntax, we see, we use the keyword any, right? After VLAN 50, we have any, and then again, the group and the outgoing interface, that would be our asterisk, G. And the third syntax here, basically pointing out for my given VRF, right? And then the fourth one is basically IPv6, pretty much similar syntax. All right, and the show under router PIM, the redistribution. Although we put it here, but it's not a new command, right? We have redistribution, but in a sense for multicast, it's new, right? Because you're going under router PIM, redistributing static. Show IP multicast static route for all VRFs, or show capacities for multicast static, or you can do show capacity status for multicast static routes. Let's take a look at that configuration example. Since we'll take a look at what the one with the redistribution. So we have again our static. So on switch 5, we have IP multicast static route, the incoming interface 1/1/43, and source being any, and destination 239.10.10.10. Notice we didn't define the outgoing interface. Well, in this case, because we have IGMP joint from the users being received on that. And then on at switch 4, you have IP multicast static route 1/1/43, the incoming interface, right? Any, and 239.10.10.VLAN 2001, the outgoing interface. Okay. Or we could have done actually interface 1/1/42. All right. So, and then on switch 3, we have IP multicast static 1/1/43 any, right? 43 is the incoming interface, 239.10.10.10 the group, and the outgoing interface 1/1/42, right? That's the static. And since we're doing dynamic with a on the left side, we have dynamic, right? Because here on the 43, we have sparse mode enabled. We're going to redistribute our static multicast into the dynamic, right? So we can build that communication between the two. Note, this PIM could have been also vendor XYZ, though it's given us the flexibility to interoperate, basically have interoperability with third-party switches, as long as they're running dynamic, because dynamic is a standard base. Our static here is a proprietary method. Best practices, there's a laundry list, but some of them I would definitely say refer to your multicast or static route user guide there, because matter of fact, some of these best practices do point you to it as well. So for things to consider and for best practices for deploying your multicast route on the network. So key things to keep in mind, you have to take utmost care because end of the day, what you don't want to do is cause issues like drops or duplicate, right? Especially with when you have concept of that ECMP coming in, when on the AG, when you have two paths, if you statically provision, we're going to send two stream from two different devices, right? So some of the best practices while configuring your multicast routes are mentioned below. Recommended, again, use it in a smaller shop, right? Because least amount of hops, right? Because it or else it becomes too much administrative overhead trying to provision hundreds of devices statically. Also, all downstream interfaces should be explicitly configured for a static multicast route where traffic needs to be forwarded, okay? If it needs to. And we already said that ECMP, equal cost multipathing, for upstream downstream is not supported because that's where you're going to have your duplicate. But there's a different types. We have different scenarios or deployment options for you in multicast static user guide. Take a look at that. And then and that's where the duplicate comes. To solve some of the duplicate issues, that's where, of course, dynamic, right? PIM dynamic solves these issues for us, right? Because then you have the designated router, backup designated, the DR router, right? That basically takes on that LAN. When you have multiple multicast PIM routers, then the DR takes the role of forwarding that stream. All right, so static multicast routes are not substitute for your PIM, right? Because again, we're not trying to remove dynamic. Dynamic is there. But anyways, because of the administrative overhead, right? It's smaller networks. But you can use summarization to solve some of the high resource usages, right? Usages. Like as we spoke about the SSDP, for example, right? Because of that discovery protocol, the chattiness definitely causes high resource utilization. So when you have your PIM plus static scenario, please refer to the multicast, because there's a list of different options you have there in the user guide, okay? And then for redistribution, please note, when you do redistribution, you have a static and dynamic. What you don't want to do is have that redistribution occur on the rendezvous point device. That's it. And static multicast routes, traffic is not guaranteed to flow the shortest path tree, unlike our dynamic, right? Because the first packet may flow, but then once we know the source, we may have a shortest path tree. We follow the shortest path tree. But with static, because we manually provision, it's a possibility that it's not going to flow through the shortest path tree. All right. So redistribution, again, when static multicast routes are redistributed into PIM joint corresponding to the static multicast route configured is sent on the reverse path forwarding interface, irrespective of upstream interface configured as part of static multicast route. The PIM joints are sent periodically based on the PIM joint prune intervals, right? And then static multicast, again, if you no longer need this, then you have to manually delete them, because there's no automatic, right? We manually programmed it. We have to manually delete them. Troubleshooting, well, again, going some of the basics, the topology, understanding of your topology, right? Because which path from the source to the destination, the physical cabling, some of the key things to keep in mind. You can use the show command, show IP multicast static route, right? But I would say definitely the ping and trace are powerful tools to test the end-to-end connectivity, physical connectivity, but from the source DR, for example, all the way to the receiver routers, right? The DR. Validate static multicast configuration. Because you're manually configuring, it is best to validate that all the way from the source DR to the client DR, right? The receiver. And also check for overlapping static multicast route. What does that mean? I'll show you in a little bit in the next slide. Check the multicast static route operations. Check for the redistribution that you have enabled. Make sure that what you're redistributing, you do see on the dynamic side of the multicast network, okay? And of course, the Datapath. Ensure that the routes are installed in the hardware. Now, check the network reachability. As we said, right, ping is the best tool to test end-to-end between this, from the source all the way to the receiver, right? And you need to make sure those interfaces, L3 interfaces, are properly configured for IPv4, IPv6. And again, we are not dependent on your unicast routing protocol. So now, validate static multicast configuration on all routers. I want to use this, again, the syntax we already spoke about, but let's use this opportunity, what we mean by, as far as your, what happens when we have a configuration of such that we have an IP multicast static route, VLAN 10, 10.1.1. Oops, sorry, I'm sorry. Let's bring it here. 10.1.2, 239, 255, 255, 250 is the destination or the group. So we have VLAN 10, the source, important point, the source is 10.1.2, the group, and then the outgoing interface. Now here, the next line, the IP multicast static route, VLAN 10, the incoming interface, and we use for source any, and it's the same group as above, but the outgoing interface is VLAN 21. Well, when you have such a configuration, what do we say as far as when it came to our unicast routing as well? The longest match is always preferred. Same thing here with this static multicast, the longest prefix match is always preferred. So we would prefer S, G, the 10.10.1.2 with the group 239, 255, 255, 250. And though in this case, users and VLAN 20 will receive the stream, but users and VLAN 21 will not, right? Traffic drop due to the SG preferred. All right, so keep in mind on that when you're configuring. Also, and then that would be the drop case. The duplicate case would be on the aggregation. Let's just say when you have the ECMP scenario and you provision the same on both, then you're gonna have replicate. Check if the multicast static route is operational. Show IP multicast static route for that given VRF, the red VRF, the group, and the source 40.40.40.2. It is static. We see the route type and what is the incoming and what is the outgoing interface or interfaces. Or you can call for a specific group. You know what? I want to see the static for this, only for this group, multicast group. Though we can see in here the group again, and notice here the source address is any. So this is a static summarized route. And the incoming interface and the outgoing interfaces. We have the list. From also, when we are redistributing, once you redistribute, you want to go one hop down on the dynamic side to verify. So we have an IP multicast static route 1/1/43, the incoming interface, the source 10.10.1.2, and the group being 239.10.10.10, and the outgoing interface VLAN 200. Now on this switch, basically, we have a routing switch. We have router PIM, redistribute static. So we redistribute the static into our dynamic. So we go on the dynamic side, show IP mroute, right? To make sure that flow, that static entry is seen by the dynamic. Group address 239.10.10.10 and the source 10.10.1.2. And again, the incoming interface, the outgoing interface, validate that is receiving on a proper interface, and the outgoing interfaces are proper, and the incoming interface, that where you learn that path from, is the correct interface. Check the multicast data path to ensure route is installed in the hardware, right? Show IP multicast routing data path. You can call for that group, for that source, and which port. So we can see in here, VRF as default. So group, actually source first, 10.1.1.2/32, and the group 239.1.1.1/32. And where is it from? Static, and it's a route type. The hardware status is active, and we see that again upstream interface, and the status for it, basically the state for it, forwarding, and the downstream, and then the state for that is also forwarding. All right. So with that said, I'm going to hand it over to Daryl. Daryl, back to you for a demo.
Okay. Right. This is my demo topology, static multicast routing. I have two switches, H60 number 1 on the left, H60 number 2 on the right. I have a source on the left, sending out multicast stream to this group, 239.10.10.10. See the source is 202.13. I have a receiver here on a different subnet, the 201 subnet, trying to get it. So this is a simple network that only requires multicast. I'll show you the switches config. You can see here, switch on the right, the left. Basically, not much there, right? IP address on the link 43 towards the other H360, another IP address towards the source. That's it. So very simple, don't require anything, just multicast, so we can enable that later. Switch on the right, same thing. Not much there, just IP address 43 facing H360 number 1. Another IP address facing the receiver. Okay, so right now, you have the source here sending the receiver, trying to get it, doesn't work, right? Doesn't get the stream. So notice again, there's no unicast, there's no OSPF enabled, there's no PIM enabled. Right? What we're going to do is just add the static routes. Okay, going to add this command in to this switch on the left. So the ingress is the SVI facing the source. This is the source IP. You can do a specific source. This is the multicast group, and this is the egress interface 43 facing the other switch. So on the switch on the right, you do the same command, but here I just modify a little bit, put any as source. This is the ingress. Source any was this group. Egress is this VLAN. Okay, so let's put in the static route on the left switch first. Online. The video has still not come up as expected. Now we go to the second switch on the right. Put in the one with the any. So after this, you should see the video start working. Okay. It's now receiving the stream. So very simple for customers who just want multicast running. You can just use this static routes, get it flowing without PIM, without other dependencies. You can show it like that. Show IP multicast static route. You can see your group address, source, incoming, and outgoing. Okay. That some additional resources related, and this static route guide is really important. Right? If you want to look at this. Thanks for this. Okay, hand it back to you, Rahim.